Hey everyone, welcome to the KE Report and a company update from Graphene Manufacturing Group, chatting again with the founder and CEO Craig Nicol. No news since the EPA approval at the tail end of December for thermal XR, but boy, oh boy, that hasn't stopped all of you from sending me your questions. Thank you for sending in all your questions, and we're going to get to as many as we can here in this interview. I just want to also say sorry if I don't respond directly to the emails that you send me. I get so many of them. Sometimes I just lose track of them, but I do always add those questions to the list that I have so that I can get Craig to address these. And there are a crossover of a number of these questions. So really helps me organize all the questions for all these calls with Craig. Graphene Manufacturing Group is traded on the TSX Venture Exchange under the symbol GMG and on the OTCQX under the symbol GMGMF. Look, Craig, the stock has been doing very well in the last couple months. Really, since December, it started taking off, and this year has been almost straight up. And I think that's been drawing a few more of these questions out too. So let's start with the battery questions. Question from the latest GMG battery update. While you release the results of the latest testing, this listener is saying it's unclear if if this is the battery design that you are progressing to consumer testing or if you're still working with battery optimization. So, can you share some details here? Are you still optimizing the battery or are you finalizing the design and moving to consumer testing?
Yeah, awesome question. Great to be back on, Corey. So the question is twofold. One is we are always looking to optimize, and it's very easy for us to optimize. We do changes, and it happens. We get responses in the same day, so we'll continue to do that. And mostly, so you've got three things in energy density that we focus on. So it's everything we do is 5, 6 minute charging. Everything we do. So anything we test on, it's all about that charging time. And that is why we continue to pull strings and get outcomes. And you've got three things you're trying to do. Increase the volts. And you might be remembering that we were used to be at 1.5 and we're at 3 right now. So we're got an aluminium ion battery at 3 volts, which is already huge. Then so you try to increase that as much as you can. And then you've got capacity. Capacities are really mixed games. The faster you charge anything, the less capacity there is. But if you increase capacity at the higher volts, at the higher speeds, you become this thing that nobody else can do, right? So that's why you keep pushing and pushing in the capacity space. And that is small optimizations of electrochemistry, some optimizations on the cathode, on the anode, and the electrolyte, and then combinations thereof. But the biggest things we're getting now is weight optimization. So that's what you divide it all by, how many grams per cell. And that's where we're getting all most of the optimizations now. Just taking weight out of making things thinner, making things lighter. So whilst you're trying to get the optimization on the top line, which is, how much capacity and volts you get, we're really hitting the weights, and we can do these, very quickly. Taking out as much electrolyte as we can, making the substrates as thin as we can, optimizing the what's called the negative positive ratio between how much weight you have on both cathode and anode. So getting all that perfect, and then you go, that's where it is. And then we'll continue to optimize. We've got complete new atom to work with that basically nobody else is working with in the world. So the thought is we'll kind of get through this next couple of weeks with some more iterations, and if things go well, we'll come out and then go, hey, look, this is where we're at. This is the next stage, and then we'll start pushing into sending out samples. So, I think we've got one of the best guys in the world on batteries on our board as a technical advisor, Bob Gullion. He'll tell us when he thinks we're at, stage gate or battery technology readiness of 5, which is when you start to push into the commercial production levels of materials. I think it's sometime this year. Obviously, that'll be important, and we'll tell the shareholders as soon as that happens.
Okay, so that's a this year type of thing, but I guess in summary, the testing's still ongoing. You're still refining kind of what the battery will finally look like. Now, in terms of some of that recent news, the last battery data that we got, somebody asked, what happened to energy density? They said that the expected energy density had dropped.
Yeah, it's a good question. And, so the coin cell energy density, we were studying and signed off by University of Queensland, and it's basically sitting at, up to 300 milliamp hours per gram or 300 watt hours per kilogram. Now, that is a combination of a number of things, and that's on a coin cell level, and it's based on a calculation that was in the press release, and it's a standard way of doing coin cell analysis because you don't have a feel of how much other stuff you're going to need to make this work, which is the pouch, which is the substrates and how thick the electrolyte, and separator and all of that. When you go to a pouch cell, cylindrical cell, you have these other things you've got to bring into account. And that, we had, if you go back through our press releases and our presentations, it always says, we can't confirm pouch cell energy density. The whole time we believed that we could still get 300 watt hours per kilogram through calculations. So that's why we kept on saying, we're good. Now, I think we've come out recently and said, we think we could probably get to 150 watt hours per kilogram. Now, that is including all the realities of scaling it. The pouch cell is it's probably 50 times bigger than a coin cell. And so you're seeing averages, you're seeing how much one separator thickness, how much electrolyte you need, and cathode and anode, and how much you need of each of those. And you bring it all together, and that's when you start to see, what the outcome could be. We had to actually develop a kind of formulation on how to, calculate the optimal outcome of the battery, the practical battery. And we actually worked for years on that. And now we have an idea how to do it, and it is interesting because it's not simple, but we found a way to do it. We worked it out, and now we feel pretty confident behind that. So we also have optimized our opportunity to get to these numbers as well. The end outcome is a battery that charges, is basically as fast as any battery or the fastest battery there is, with an economic energy density. And you start to get to that energy density pretty quickly with this. It's 100 watt hours per kilogram is the magic number. You don't really need 200. If you had 200, there, that's just completely out of this world. 100 is already enough. 100 is so massive because basically what we're expecting is that is not going to be needed to be cooled. And as a result, that's equivalent to about 150 watt hours per kilogram of a lithium ion battery. And then if you can do that at, in 5 minutes, there is, nothing like that. So that is why we also came to understand what is really needed of this type of battery. And 100 watt hours per kilogram is a really good number to have within, 5 minutes.
So, Craig, a couple of questions on Super G then. What testing's being done, and what are the consumers or the people testing saying about Super G?
Yeah, so the testing is behind closed doors, big companies, and they're in lithium-ion battery value chain. They're basically saying it provides better rate tolerance. They can charge their batteries faster, and they can store more capacity. So increase cooling efficiency, increase energy round trip efficiency. So basically, almost everything you want, and I think it increases the voltage slightly as well. So the thing is, we've got to work out how to get it to the lithium-ion battery industry so that it links in with their value chain. They're used to getting rocks, smashing them, and making their own graphite, sorry. And that is a real feeling that they need to control how the material gets to them. That's what they do, right? They make it from raw material all the way through in their battery plant, and then they get it to their end battery. And that's so when we come and say, hey, we've got a liquid, you could, just literally pour that into your factory casings. It's just becomes an interesting, disruptive conversation. So what we're learning is how to get this to them in a way which they can deal with without too much disruption. So that's one of the things we're working on. The conversations are good. We need more and more testing. The testing has to be really consistent. So we need consistent data baseline, and then we add the lithium, and then we add our additive in, and then we get that difference. We're trying to do multiple parties now to do as many testings as we can there. And then we'll come out once we have really clear testing on both sides. We've had some fantastic results, but We don't want to come out with until it is really, really clear and clean that what we have.
Now, BIC, your relationship with them, that is the US manufacturer of batteries. You're using them to help develop these batteries as well. And on the manufacturing side, do they have access to this testing? Are they doing testing as well?
Yeah, yeah, they are, and that's exactly what one of the three things we wanted to work with them on when we approached them. The aluminum ion battery development with us, where we make them, send the materials, they then develop them into pouch cells. They got all the tech equipment and process and people, and then Super G as well as then using our coating on battery packs. So we're working through all those. There's a lot of activity in this space, and we work with them on a pretty consistent basis, with a large number of people over there working with us. So we'll get through things, and then we'll come out as soon as we know that what we have is, backed up by what they think and we agree is all consistent data. There's a number of ways you can misrepresent, and we just don't want to do that. We want everything to be clean and clear. All that battery data that we came out with around our graphene aluminum ion battery was all signed off and done by the BIC. We got exactly the same data in Brisbane. Then we got it a week later in Indiana. So then we said, okay, let's publish. And that's what we want to see as well on pretty much everything else we do.
Okay, let's move on to thermal XR then. With the EPA approval, what can you tell us about what you can ship to the US? If you started shipping, any updates on what's going on in the US with thermal XR now that that EPA approval is done?
Yeah, so we've got the consent agreement conditions. We haven't actually got the consent agreement yet. And that's the thing that we need. And that's supposed to be imminent. And we're just waiting on that. We've got fantastic consultants who know what's going on, and they're working with people there to make sure that everything's lined up. It's a big thing. I think it's either the first or second graphene product to have an unlimited EPA approval. So it's not a small thing, for the industry, certainly not for us. We're very excited, and we're very excited to work with New Calgon. They're a great partner, and yeah, lots of opportunity to really change the market in the North Americas with this. So we can't ship anything until that consent notice is signed. Then once it's signed, it takes about a year for it to actually get into law. We have the ability to ship under that, but when it becomes under law, other companies can ship under it, but they've got to use our graphene and effectively similar graphene, and they've got to use very similar processes and paint. And so it becomes very hard for someone to actually ship under it unless they kind of get to know and understand everything that we do, which of course, it's a lot of trade secrets and also a patent as well. So it is a big barrier to entry. We've worked hard at it. We're going to push through. We're going to get this consent order notice. We'll then tell the market that we've done that. We'll ship, hopefully the same day that that consent notice is actually signed. We are shipping small R&D samples for different project evaluations, into Mexico, into Canada, America already, and into the Caribbean. But obviously, then once that consent notice has happened, we can start shipping in 1,000 liter Palicons.
So, talk to us about the total addressable market size then that you're currently focusing on, because it's unlimited, the emails that I get in terms of have they tried this product here? Have you tried this product here? In terms of what the target market is here and now when you can start shipping these, give us insights on that. What is it?
Yeah, so there's at least a $20 billion installed market that we can go after. That's basically 10% of the world's air conditioners. And so, that's a lot of paint, a lot of graphene. So that's installed market that's seeing, that would get a large cut in electricity if they use that product and then extend their warranty, or they'd have a warranty from our coating on their air conditioner once it's applied. So they get 5 years if it's applied by, certified professionals. So there's that. Now, that is a big market and some really immediate cost savings for people who have the coating and the paint and the air conditioner. So that's why we feel the installed market is good, and that's New Calgon certainly, with their 4,000 distribution points, is kind of well and focused on that. There's the new to market air conditioning paint opportunity, and we see that as about $1 billion a year. So the new air conditioning systems every year, we see that as about $1 billion a year in terms of the market size. The LNG market we see, sitting I think it's just under $1 billion of opportunity. The opportunity to increase their process production flows is there with our coating and reduce corrosion because they're all sitting on the ocean seafront. Then you're sitting with the electronic space, and you are talking at least $1 billion there of paint. Now, when you start talking data centers, we've done some work with OEMs just recently, and we've really got to get our head around it. Basically, it sums up around 1 liter per NVIDIA chip. That's what we can do. Generally, we can do at least 10 to probably 15% energy saving on your chip cooling. So, if you calculate how many chips there are, that's, how many liters we'd probably have for the coating. And, we're getting access through multiple different countries and OEMs and service providers and also universities, institutes, all looking at testing the product for optimizing the electricity bills. So, the market is large, and really the data center space has kind of bloomed over the last year. It's certainly with the AI. AI data centers consume about 6 times more energy than a normal data center, and it's all about heat removal, and it's an enormous problem. I think current NVIDIA chip is about 600 watts, which just means 600 watts of heat needs to be removed. And this year they're aiming to get to 1500 or 2000 watts, but by 2030 they want to get to 15,000 watts per chip, and that's just all heat. So all heat's got to be removed. We double the heat transfer rate on any metal we attach to. So we're just an obvious choice to help with those efficiencies. So that will, I think, blossom into more and more opportunity and sales. So we're very excited about that.
So, Craig, in summary for Thermal XR, have there been any significant sales so far, or is that a, let's say, later Q1 or Q2 type of thing?
Yeah, so we've got distributors buying. We've got, in small packs. We have got, some large companies progressing through their material, opportunities, with using it internally or reselling it to their customers. And then we've also got, obviously, the Bayer rollout, which is really material. It's basically the biggest in the world in what they do. And Australia's 25% of electricity used on air conditioning. So you probably couldn't have bigger opportunity kind of announcement. And that's really seen in the industry as a big step forward. So as that gets rolled out, I think you'll see, those sales come in, and then, the opportunity to do that in other countries, other players is there. And so, that's building. It is a slow market to respond. It is a very technical market, very analytical. They literally move heat through walls by magic. So they've got a system to make sure everything they do is ironclad. No one wants an air conditioner to break down, and so they've got high quality precision. We're obviously across many different industries, which is we're able to see the differences, and that means that they are very rightly skeptical. So we just got to keep building momentum, getting data, getting more customers on, and we'll just keep building the case. Really, in the end, there is nothing stopping this should just being everything should be covered in this coding, every heat exchanger. There is no reason technically why it shouldn't. It's just, is the market going to get there, and how fast it's going to get there?
That's a lot of the questions that I have then is how quickly is this happening? And well, is it even happening right now? So I'm sure I'll keep asking you those as I keep bringing you on. Let's move to G Lubricant. Expected EPA approval date for G Lubricant. What can you tell us about where that is in the process?
Yeah, so we've got some information on that, and we're going to have to go through another EPA approval for the G lubricant. That's the current thought on the table right now. So we'll be coming out on that shortly on what we think it's going to do. It won't be exactly the same full length because now we've basically got this approval in place for the graphene. So that enables EPA to get to the next stage a lot easier. So we will have to apply though for the G lubricant to be approved. So in the meantime, we're working through potential partners, distributors in America, and obviously then working on other partners around the world. The difference that graphene approvals in America is to say Europe is that Europe has tested, in their eyes, all sorts of graphene, and they've said therefore graphene is approved. and there are limits, and you can go and sell it in, and as long as you go under what's called the only administrator agent system. Whereas in America, they see, and probably rightly so, but they still need to work through each individual graphene, and as a result, they find that they need to go through each different process to understand what the graphene is, and that's the difference you're seeing. So when we ask to go and use it in another way, the EPA with an engine oil, the EPA needs to go and assess the risk. And so we submit all the documents with our consultants, and then they need to go through that process. So in the meantime, we'll be building the momentum in the North America's markets, and we'll come out once we're clear on exactly the timeline. We'll come out and tell people.
Okay, when it comes to the testing of G lubricant, any feedback in the truck fleets that are using G lubricant, and have they by chance moved beyond just testing to formally being used in all or most trucks?
Yeah, I'm still doing testing. It is difficult. Some of these tests have been going on for more close to a year now. So I guess bear with us. We'll come through. We haven't had a bad result yet. People generally see immediate changes in their own cars or vehicles, and we've just got to keep progressing through this. It's like it's got to get to a critical, mass in the market, and then people start to progress. We've got a number of OEMs working through testing. We'll come out with more data ourselves on this testing as well, because we've got the engine refitted with a whole lot more thermo transducers, which will enable us to get a whole lot more data on the next tests. It takes a lot of work to test these fuel, consumption reductions, to get them stable and get reliable data that we can back. So yeah, we're working through that as well. We're not absolutely in any way resting on what we've got. We're putting in sales teams and around the world, and that also makes obviously the conversations with customers happen faster as well.
Now, what about Rio Tinto? You're working with them on the battery side of things, but somebody noted, hey, couldn't G lubricant be used in their diesel powered stationary generators? They note that could be a huge market. So, broadly, could Rio Tinto use this? Is Rio Tinto using this? And where could they use it?
Yeah, I think, basically any diesel engine and power generation, truck, bus has, obviously even gasoline, petrol engines can use it and they see benefits. We're in a process of discussions with, various different companies, going through the process of seeing what they need from us to get this into trial engines, and then beyond into actual production vehicles. So, I think Rio's definitely, in the mix, and there's a lot of companies we're working through on that.
Well, Craig, clearly there's been a lot more interest in the graphene sector. We keep hearing about all kinds of other companies looking to apply graphene to all kinds of different areas. So, question being, one person brought up solar panels to either replace silver electrode or mix it in with the silver to cut the cost, especially now that silver is running. Can you talk to this? Does any of your products, could Super G work within solar panels? And are you actually developing any new products, or are you focused right now simply on the three main products that you have currently?
Yeah, great questions. Graphene can be featured in almost every part of a solar cell and improve it, making the heat out, fastening electrical transfers, energy storage, yeah, you name it. We've done some work, but very little. We mainly focusing on our coating on the back of solar cells, which can reduce, we've shown them to reduce the temperature up to 20% and increase power production by 10%. But look, solar cells are really cheap to make and buy right now, and we saw the market as not optimal to go into. We've got many ideas that keep pushing together. They've got to get through a pretty tough process. Currently, we're just focused on our existing products, and they're all mass use, single one product, multi application. That's multi country, multi different way of using them. That's the optimal revenue, low cost focus that we've got, and I think it's going to pay dividends. We can always bring another product to market, and there's so many. It's really nuts, to be honest. It's actually one of the problems of being in a graphene space is you would have focus to get through. So yeah, we are very happy where we are now. There are other products. We've got one particular graphene coating, which often comes up, is a clear coating, which we can now do. We can actually now make a clear coating, which is pretty cool. And so, that's another one that's out there. But yeah, all mainly focused on existing product market applications, because they're big enough and they can take us for years to fully get through.
All right, so big picture question then. Break down the goals for 2026. Somebody asked 2026 and 2027, but let's just focus on 2026. What are the big picture corporate goals?
Yeah, so we want to see obviously the consent notice and then large volume TXR sales to America. We want to see distributors around the world getting small packs distributing into retail sites around the world. We want to see Bayer roll out nicely in Australia and get revenues there. We push for more detailed upgrades, update details on Super G. We'll definitely get more detailed updates on the battery progress and partners. We'll also, be coming out with progress in our North America expansion, because that's really the next phase. Once we've got obviously Gen 2, which is our 20 times production upgrade going in and expected to be switched on in June. Once that actually comes online, we can then make a large amount of graphene, very low cost, in large production runs. Obviously, in America is where in Canada is where we want to put those plants with the low cost natural gas. So we'd hope to do that as well this year. We'll start to show, the size of the sales team that we're building. We intently focused on sales teams growing all over the world in the last 6 months, been almost entirely what I've been doing, focusing on. And then you should then start to see some really good sales. So all of that, this year is on the cards. It's just when and then what else is coming, because there's a lot going on.
Okay. Craig, one other thing that's going to happen this year, I'm undoubtedly going to keep having you on the show and keep answering these questions because they keep coming in. As we're recording this, I even got another question come in. So I will follow up with you in a few weeks, cover any news that has been released, and also continue to answer these questions. So please, everyone, just keep sending me your questions, and I'll keep bringing Craig back on the show. Again, Craig Nicol, founder and CEO of Graphene Manufacturing Group. Click the link in the show notes to visit the company's website. Keep sending me your emails. Craig, thanks so much for taking time with us today.
Thanks, Corey.